just want to add one quick thought that I left off at the end of the previous video. So if you remember, in the previous video I injected a pink noise trace and was looking at how this changed the membrane potential. And on the left here, this is the two signals in the time domain, and on the right, this is the frequency domain, which you can go between these two by the Fourier transform and inverse Fourier transform. So what I in the previous, what I forgot to mention in the previous video was that if you look at this noisy input, you can actually see features of this input within the membrane potential. So for example, this bump here is a good example that actually gets translated quite well into the membrane potential. So in other words, this low frequency component of the signal passes through the low pass filter of the passive membrane. It passes through the low pass filter, and you can actually see a similar bump in the membrane potential. On the other hand, if you have other signal parts of this input signal, such as this very tiny bump here, that this signal comes down and there's a little bump right there. This little peak, you can also, if you look very closely, you can look at and see it in the membrane potential trace, but it's much smaller than the larger peak I just mentioned a second ago. And then finally, you can look at even smaller components, or even higher frequency components, like anything within this band of this input signal, and that stuff just sort of gets filtered out. It's almost completely absent if you look at the high frequency content in the signal versus the same point in the time in the output membrane potential. So, and you can also, if you look in the frequency domain, you can see a similar thing. So this second peak here corresponds to this very large peak here, and this peak in the input signal is somewhat diminished in the actual signal, but it still passes somewhat effectively through the filter. So, and then if you look in at a smaller peak like this peak here, that also shows up to some extent, but it is diminished even further in the output signal. And if you look at a signal down here, this high frequency content is completely filtered out by the low pass filter of the membrane. It's just completely absent in the frequency domain of the membrane potential trace. So this is really why, the reason I wanted to mention is this is really why we call this a low pass filter. It's a filter that passes through certain amounts of frequency, and in particular, low pass filter allows low frequency content such as this to pass through preferentially, and then essentially erases out or diminishes all this high frequency content up here. And you can see that particularly well within this pink noise trace. Okay, so that's it. I just wanted to make that quick clarification, and I will see you in the next video.